Pi over 2.
Okay, pi over 2. What is tangent of pi over 2?
0.
Undefined. Okay, tangents. Remember the vertical line, tangents undefined. Y over x.
Yeah, pi. Oh.
3 pi.
3 pi over 4 is
Negative 4.
Will we ever have to like recreate these tables?
No, but if I ask you any tangent of any of these things, should you know all of those from the unit circle? Yes.
Would you expect us to memorize? I mean, we haven't memorized all this.
I don't want you to ever look at this picture. Now, if you draw individual triangles and stuff like that, that's great.
I'd rather draw circles.
Okay, well, you don't have to draw the whole thing, though. Because it takes you. Like, if I just want to find tangent of pi, just draw that. You know what I mean? But you are. Okay. Stop my hand this morning. Where do these come from? How do I find them if I can't remember? Okay. Right. So if I'm looking at 3 pi over 4, I know that's a 45-degree angle in quadrant 2. It's a 1, 1 radical 2. It is negative because it's going that way, so opposite over adjacent would be negative 1. So that's how you find 3 pi over 4. Now if I am talking about something like 3 pi over 2, so one of the quadrantal angles, those are kind of the ones that you're just going to have to memorize the point on the unit circle, and then remember tangent is y over x, so negative 1 over 0, which would be undefined. So even though you may not have to write the table from scratch, the points on it are ones that you will have to know. They will go back up on this test. This next test will have another unit circle page like the last one. Not where you have to fill the whole thing out, but where it asks you things like posting in a fire suit. Hopefully it's easy for you. We hope it's easy. We hope you still remember it. I will remind you before we actually get to the test, but I hope so. I'm going to remind you of that as often as possible because that is the most important thing that you leave trig with, is that unit circle. It's the thing that you have to know every day in calculus. You have to know how to find those points on the unit circle. There are a lot of things that we will do in trig that are more in depth than necessary, and as far as calculus goes, but not the unit circle. That you have to know that front and back, through and through. So that's why I did a mastering quiz on it. Okay, let's do a few more. 5 pi over 4.
Yes.
3 pi over 2.
Undefined.
7 pi over 4. And 2 pi.
0.
And we could have gone backwards and done some more that way also, right? When I'm plotting, I may even need a little bit more than that. We'll see. What do undefined show up as on a graph?
Vertical asymptotes.
Vertical asymptotes. So they could be holes, but for trig function, they're asymptotes because we get a number over 0. So at pi over 2, so if I call this 2 pi, at pi over 2, I have a vertical asymptote. Would you agree I also have one of those at negative pi over 2? We didn't do that point, but agree that negative pi over 2 tangent is also undefined. At 0, tangent is 0. I didn't figure that one, but I'll agree at 0, tangent is 0. At pi over 4, tangent is 1. At negative pi over 4, I didn't do that one, but it would be negative 1, agree?
Yes.
And we could do more points in between if we wanted to, but those are vertical asymptotes. So don't you think we will probably approach those?
Yep.
That's close to those. Approach infinity. So this is what a tangent graph looks like. This dotted line. Oh, sorry. I'm labeling this pi. That needs to be 5 seems to repeat itself after that. How often does it take for tangent to repeat itself?
Period.
Pi, right? So the period seems to be for tangent to only be pi. That's kind of strange, isn't it? Every other function we've looked at has had a period of 2 pi originally. So tangent actually has a period of pi originally. So it's a little different. So let's talk about the tangent function, just like we did the other functions. So we're just adding one more to our, 2 more, because we'll do cotangent as well. It defines vertical asymptote in this chapter. I don't know why it define it when we didn't see it, but we'll take it. Vertical asymptote is a vertical line that the graph approaches but does not intersect, while the function values increase or decrease without bound. So we get closer and closer to those asymptotes. The tangent function has a domain a lot like cosecant, because sine. When sine 0, right, when the y value is 0, we have those undefined values. Wouldn't that have it the same like cosecant and tangent? All the asymptotes kind of fall in the same place. Would you agree? Or sorry, secant and tangent. Because you're dividing by the same 0. So your domain is all x's except the odd multiples of pi over 2. That looks familiar. You've seen that domain before. The range is negative infinity to infinity, because the y values, there's every y value in between. And so a 1 period of tangent looks like that. We could graph as many periods as we wanted to. It does go from negative pi over 2 to pi over 2 is the normal 1 period of tangent that we will graph. Now you could scoot it over and get from pi over 2 to 3 pi over 2. It doesn't matter. But 1 period of tangent, we're going to generally draw from negative pi over 2 to pi over 2. Has discontinuities at all the odd multiples of pi over 2. It crosses the x-axis at every multiple of pi, which makes sense. It's 0 pi, 2 pi, 3 pi, 4 pi. It's going to hit the x-axis at all of those. Its period is pi. Still has no amplitude since there's no maximum or minimum. And it is symmetric with respect to the origin. It has the origin symmetry. If you rotated it around the origin, it would fall on itself. Sine also has origin symmetry. We'll talk about that when we mention sine. Cotangent looks similar, a little different. I would draw 1 period of cotangent. It also only has a period of pi, very similar to tangent. But its asymptotes are at 0 and pi. Does it make sense that its asymptotes would be at 0 and pi? Yeah, because it's undefined where tangent is 0, right? So it has asymptotes at 0 and pi, and it is oriented the opposite way. Tangent goes up to the right, cotangent goes down to the right. So you'll just want to memorize kind of the differences in those two. If you forgot one, could you pull 3 points off the unit circle and figure it out again? Yeah, so if you forgot how it goes, just plot 3 points really quick and remind yourself. Did you ask a question? The domain is every x except where the asymptotes are. Those happen at intervals of pi. The range is negative infinity to infinity. As you can imagine, we're going to take these and we're going to transform them like we have done all the other truth functions. As far as that part goes, that should start to kind of feel like old hat stuff. We've done lots of transformations. Tangent's a little different though. There's a few little differences. This is just the other information I gave you for tangent. Discontinuities at all the multiples of pi. X-intercepts at the odd multiples of pi over 2. You can see those are flipped for tangent and cotangent, because when tangent's 0, cotangent's undefined, and vice versa. The period is pi, has no amplitude since there's no maximum or minimum, and is also symmetric with respect to the origin. It also has origin symmetry. Looks a little different, but it's still, if you rotated it at 180 degrees around the origin, would fall off. If you go to type tangent or cotangent in your calculator, if you type cotangent in, you can use 1 over tangent. Now, I would actually recommend cosine over sine. If you do 1 over tangent, your calculator struggles with the zeros because tangent's undefined there, so you can't graph them at all. Even though you know it's 0 there, your calculator struggles. So a better way to graph it is cosine over sine, which kind of lets you know how else could you graph tangent besides typing
Sine over cosine.
Tangent would be sine over cosine. I didn't know that yet, but for cotangent, you do need to know how to type cotangent in the calculator. Both of those work sort of. Let me show you what I mean by sort of. What is the cotangent of pi? What is the cotangent of pi over 2? Cotangent of pi over 2 is 0. Type 1 over tangent of pi over 2 to your calculator. Here's one equation you have to figure. Type 1 over tangent of pi over 2. What does your calculator say if you type 1 over tangent of pi over 2? Why does it say error? What's the root of the error that it's giving you? You can't do tangent of pi over 2, right? Agreed? Your calculator cannot do tangent of pi over 2. So it's shooting back an error because tangent of pi over 2 is a problem. But cotangent of pi over 2 is 0. We know that. Try cosine of pi over 2 divided by sine of pi over 2. What does it tell you? In radian mode, of course. It tells you the 0. So the one on the left works great as long as you're not doing one of the angles where tangent is undefined, but that is one downside of your calculator if you use 1 over tangent. If you know those from your unit circle, then it doesn't matter anyway. You can kind of ignore the calculator's error there and fix it on your own. But if you want your calculator to pop out correct answers even on the quadrantal angles, then use the cosine over sine. Okay, how to graph tangent and cotangent. There is one big difference in everything you've done so far in tangent and cotangent. Other than that, everything will be about the same. The one big difference is the period. The period of tangent and cotangent is pi. So when you get the new period, you do pi divided by b and not 2 pi divided by b. Okay. So the period is pi divided by b. Now let me again say why. Normally you do 2 pi divided by b because you would divide the original period by the b value to get your horizontal shrink. So the original period on tangent is pi, so when we divide to find the period, it's pi divided by b. Then I'm going to plot my vertical asymptotes. They have a weird equation they're solving. I'm not going to solve that equation. For tangent, I'm going to plot asymptotes at half the period, front and back. So if I did 4 tick marks, I'm going to plot asymptotes half of the period, and then I'm going to go backwards half of the period. For cotangent, I'm going to plot them at 0 in the period. And I'll show you a picture when we graph one. So I'm going to do half of the period for tangent, and for cotangent, I'm going to do the whole period, is where the asymptotes are going to be at. They have a weird equation they're solving to get that, where it ends up giving you half the period or the full period. Sketch the vertical asymptotes. It says divide the interval into 4 parts. I'll actually do that on step 1. Evaluate the function at the quarter point, the midpoint, and the third point. We're going to memorize the 3 points on tangent, and we're just going to sketch them. like we have on every other graph. And then join the points with a smooth curve approaching the asymptotes. So I'm going to graph tangent of 2/3 x. What's the first thing I'm going to do? Find the period and the non-amplitude, but we'll call it amplitude, it's fine. It's not really amplitude, but we're going to find the period and the height. The period is 2 pi, no, not 2 pi. What is it?
Pi divided by 2.
Good. Pi divided by 2/3. Flip that and multiply, so I get pi times 3/2, or 3 pi over 2. So I'm still going to make 4 tick marks, and I'm still going to make my 4th tick mark 3 pi over 2. And that should feel familiar. I've always done that, right? So I'm going to make 4 tick marks. I'm going to make my 4th tick mark 3 pi over 2, make it the period. I'm going to look and see which one I'm graphing, and I'm graphing tangent, right? So I'm going to go to half of that period and draw my asymptotes. And backwards. So the asymptotes on tangent will split the x-axis or the y-axis. So my asymptotes are actually at half of 3 pi over 2, which is 3 pi over 4. So my vertical asymptotes on this are at 3 pi over 4, negative 3 pi over 4. But half of wherever your period is where those asymptotes go. Does that make sense? And then I'm going to memorize the graph of tangent 0, 1, and negative 1, and I'm going to sketch that. What do you think would change if the amplitude was a different number? The 1 and negative 1 would be up at different values. Right? The vertical stretch, it would stretch those 1 and negative 1 to different values. Any questions about how to graph tangents? If it said 2 periods, what would I do?
Draw another one.
Go 4 more tick marks out and draw another piece. Is this okay? Alright. Cotangent. 3 cotangent of 1/2 x. What's the first thing I need to find? The period of the, we'll call it amplitude. We know it's not really amplitude, but it works. So the period is pi divided by 1/2, which means my period is
2 pi.
2 pi. I'm going to go 4 tick marks out, and I'm going to make my period. So we're going to do that just like we did with sine, cosine, secant, cotangent, everything the same there. 4 tick marks out, make the period my 4th tick mark. For cotangent, the asymptotes are at 0 and the period. For tangent, they're halfway. For cotangent, they're 0 and period. Cotangent goes the other way, right? So it is at 0 in the middle. At the first tick mark, normally it's at 1, but what is it on this one?
3. No, 3.
3. And then this one will be at negative 3. If you were to graph this in a calculator, you know that it would keep going, right? There would be one of those. It would just continuously look like squiggles. So we are only graphing 1 period. There is more, but one's enough. Gets us the gist. Any questions about that one? It's trying to trick us. What do I mean by it's trying to trick us? It put the vertical shift in the front. As soon as I see that, I'm going to move it. So I'm going to graph a normal tangent function, and I'm going to move it down 3. How do I graph a normal tangent function? What is the period? Pi. normal tangent, negative pi over 4, 0, and pi over 4. I know those values are negative 1, 0, and 1. From my unit circle, if you were to forget them, you could get them back from your unit circle. So this is the original tangent graph. And what am I going to do? Take it up and move it up or down 3 units. Does moving up or down move the vertical asymptotes?
Yeah, the second.
Did I? The middle one? This one. Thank you. It'd be good if your true teacher can count. Maybe your class teacher will be better. Any questions?
Go to the record.
That's the way you figure out how to spend time.
Okay, any questions about that one? What?
Think you're thinking.
Okay, let's try one with a phase shift. Left and right. They follow phase shift. It's the horizontal.
Our homework, I was doing that.
Okay, let's look at this one. It is a normal cotangent graph, but it's shifted left pi over 2 and up 3. Everyone agree? So I'm going to graph a normal cotangent graph. I have my mark is pi, my asymptotes are at 0 and pi. Remember, cotangent is backwards of tangent, so it starts at 1, 0, then negative 1. So this is my normal cotangent graph. How many tick marks is pi over 2? 2 tick marks. How do you know? Half a pi, right? So pi was the period, pi over 2 is half of that. So 2 tick marks to the left. And so I'm going to pick up each vertical asymptote and move those 2 tick marks to the left. And then I'm going to pick up each point. Are y'all okay if I move left and up at the same time? That won't hurt anybody's. Okay.
You get up.
Left, 2 tick marks, and up 3. Shift the vertical asymptotes left, and then shift all the points left and up. So the blue graph is the final answer. Any questions about that? Okay.